Assalamu alaikum, this is me Ikra Ali. We are going to discuss about soft ionization techniques in mass spectroscopy today. Before heading towards the main topic, let's understand first some basic concepts in mass spectroscopy together, and let's understand what does mass spectroscopy actually mean. It is an analytical technique used to quantify or identify the chemical composition of a sample by measuring mass to charge ratio of ions of an analyte. Mass spectroscopy actually involves ionizing a molecule first, then it separates their ions on behalf of the mass to charge ratio, and finally it detects them. What are ionization techniques? Whenever anyone have to analyze a compound under spectrometer, they cannot normally do it. They first breaks the compound into its ions or fragments, or they just convert an analyte into their cations forms, and these cations undergo through a spectrometer, and spectrometer detects the masses of these cations and gives a graph at the end. This type of ionizing or breaking or fragmenting an analyte is just called as ionization techniques. As we get a graph at the end of a mass spectrometry, as a result, it means a graph must contain information about an analyte, and this information is known as mass spectrum. And this mass spectrum depends upon ionization techniques in a way that which ionization technique is we using to fragment an analyte, and which type of technique gives how many number of peaks, and what are their m plus peak values. So further including a word that m plus peak values. What does m plus peak values means? M plus peak values just known as the intensity of a peak. We can study a spectrum in through two parameters. Number one is number of peaks, and the second one is intensity of a peak. As we first discussed about the number of peaks and intensity of peak, like that, both of these parameters just depends upon the ionization techniques, whether which type of ionization technique we are using to fragment an analyte. Here are some types of ionization techniques. The main types of ionization technique include hard ionization technique and soft ionization technique. Whenever we use a hard ionization technique to fragment a molecule, it requires large number of energy or high energy, because in hard ionization technique, before analyzing an analyte under a spectrometer, we fragments a molecule into large number of ions, so it requires higher energy. On the other hand, soft ionization techniques requires less energy as compared to hard ionization energy, and less fragmentation of molecular ions. Some examples of hard ionization technique and soft ionization techniques. Electron ionization is the type of hard ionization technique, as hard ionization techniques require higher energy. So electron ionization technique requires 70 electron volts of energy to fragment a single molecule into its ions. Soft ionization technique examples are chemical ionization, fast atom bombardment, matrix assisted laser desorption ionization, which is also known as MALDI. We will discuss in detail chemical ionization and MALDI further, but a little bit about fast atom bombardment, including here that in fast atom bombardment ionization technique, we just bombard an atom which leads to fragment a molecule. So let's discuss in explain about the two soft ionization techniques. The first one is chemical ionization, which abbreviation is capital CI. In chemical ionization, we actually uses a reagent gas like methane, ammonia, or isobutane. The reagent gas first ionizes by an electron, and then this ionized reagent gas further reacts with an analyte and then ionizes the analyte just by transferring a proton. How does it actually works? It works in 3 steps. The first one is ionizing of reagent gas, as we have discussed earlier that the reagent gas which we are using first ionizes by an electron. For example, we have a methane gas which is ionizes into cation by just losing an electron. The second one is formation of reagent ions. The primary ion means methane gas, which we were using in our first step, will react with the the cation of methane gas, which was formed in the first step. These both will further react and form two ions like a protonated CH plus, CH5 plus, and CH3, a methyl ion. The last step is reaction with analyte. The protonated methane will further react with an analyte and it will transfer its one proton to analyte and ionizes the analyte as MH plus. It has some advantages and disadvantages also. Advantages include the chemical ionization is better for identifying molecular mass. It involves less fragmentation, means which gives cleaner spectra. It is suitable for sensitive compounds. Disadvantages include it requires a reagent gas. Sometimes interpretation of spectra can be complex. It is not suitable for all type of compounds.